Hey everybody! Since working with quadratic equations, we've looked at many different ways and strategies to solve a quadratic to find our x-intercepts. Initially, we learned 3 shortcuts to factoring. We learned the greatest common factor, we learned difference of 2 squares, and perfect square trinomials. After that, we looked a little bit about factoring, where we find our a times our c, sum 2 numbers that multiply to that, but then add to our b. And then most recently, we've been working on completing the square, where we move our c over to the other side, make it a perfect square trinomial, and then go through all the steps to solve it. We're going to now look at the last strategy to solve for our solutions, okay, which is using the quadratic formula. Now, I think there's a couple classes that I showed this to initially just to kind of intimidate you a little, I guess. It's a pretty big, nasty equation, but it actually is going to make your life really, really easy because you can use it all the time, every time, whether your solutions are going to be rational, irrational, or complex answers. So, the quadratic formula can be used always to solve for your solutions, which are your x-intercepts. Okay? Now, the quadratic formula itself is pretty hefty. This is something, I hate to say, you're going to have to memorize. The formula is negative b plus or minus the square root of b squared minus 4ac over 2a. Now the a, the b, and the c used in this entire formula comes from our standard notation, which is ax squared plus bx plus c equals 0. So this c is the c used here, the b is used here and here, and the a is used twice here. When we go through solving this, we need to make sure we use our order of operations. Now there is a pretty hefty process where we go from here and through many, many steps, we isolate our x's. Even though we have an x squared and an x, the algebra involved to combine those and solve for it actually gives us this equation. This gives us what x equals. I'm not going to walk you through those steps, and I'm not going to make you memorize those steps. So honestly, we're going to kind of glaze over that part, and you have to take my word for it that this can be changed into this form where x equals this piece. If you are still really curious about how that came about, it is in your ebook under section 4-6, quadratic equation and the discriminant. So feel free to check that out if you want to, but I'm not asking you to. So this chunk here, memorize it. Write it down, star it, okay? I'm going to walk you through how we can use this formula with a quadratic equation to find our x-intercepts, our solutions, okay? So the first thing we're going to want to do, like always, I'm writing some steps down, is I want to make sure my equation is in my standard form. So if I need to, I'm going to put it in standard form, which is this type. So here, I'm already pretty close to standard form. All I'm going to do is subtract my 11 from each side, move it back over, so that my equation is set equal to 0. So I'll have x squared minus 10x minus 11 equals 0. Now at this point, normally, I have a couple options. I can see, is this a perfect square trinomial? Well, 11's prime, so it's not. I could complete the square by moving this over and finding my perfect square to put there. I could factor it by doing a times c. Okay, all of these are strategies that I could do. But another strategy that I could do is to use the quadratic formula. So, I'm going to outline what my a, b, and c are that I'm going to use. So my a here obviously is 1, my b obviously is negative 10, and my c is negative 11. All I'm going to do now is plug those into this equation, okay? So this is my step 2. My step 3 is going to be to plug it in. So I have negative b. So this is a negative of negative 10. I'll simplify it later. Plus or minus. So we know that means and shows us how we're going to get our 2 solutions. One of them is going to be the sum of our numerator. One of them is going to be the difference of our numerator. I have the square root symbol. Now I have b squared. B is negative 10. squared minus 4 times my a, which is 1, times my c, which is negative 11. And I have to extend that square root sign. All of this is going to be the piece that must be solved first via our order of operations. This whole thing, it looks super nasty, but it's actually going to, with algebra, even out to be some nice numbers here. All of that is going to be over 2a, and a is 1. So let's simplify this down a little bit. Okay, I'm going to start by doing my negative of negative 10, which is a positive 10, plus or minus the square root. Negative 10 squared is 100. Minus. I'm not going to do 100 minus 4. Order of operations says I need to make sure I multiply this chunk before I do the subtraction. So I'm going to do that right now. I have a negative 4 times 1, negative 4, times a negative 11 is a positive 44. So this minus is going to become a plus 44. And all of that is going to be over 2 times 1, which is 2. We're going to continue solving this now. Okay, I'm going to simplify again inside my radical symbol. So I have 10 plus or minus the square root of 144. All of that is over 2. I'm going to bring this piece right up here. I know it kind of messes with your notes a little bit, but I need some space. So I'm going to have 10 plus or minus the square root of 144. The whole thing's divided by 2. Now I can simplify the square root of 144. Hopefully you know that by heart. 144 is a perfect square. It will not always be a perfect square. Okay? Sometimes we're going to have an irrational number here. Because this is a perfect square, we're going to get a nice rational number. 12 times 12, or positive 12 times positive 12, negative 12 times negative 12, is going to give us that 144. So I'm going to plug that in. So my two solutions here are going to be 10 plus 12 divided by 2. So 10 plus 12 is 24 divided by 2, which can simplify to just the number 12. Or I could have 10 minus 12, which gives me a negative 2 over 2, which results in a negative 1. So my set of solutions here would be negative 1, 12. Now I know we jumped around a bit, okay, and I didn't finish my steps. So maybe I can do that as I sum up our work. The first thing I did is I put my equation in standard form. So it's an ax squared minus bx plus or minus c, okay, equals 0. This is key. It needs to be in this form. After that, and I know you guys probably don't need to write this step, but I'm just going to say it, you need to make sure you know what each of your a, b, and c are, okay? If I list them out like this, as I plug them in, I'm less likely to make a mistake. Next, initially you're going to have to look at your notes, but hopefully you will memorize. You just plug in those values into negative b plus or minus the square root of b squared minus 4ac. The whole thing is divided by 2a. I just plugged it all in. Then I'm going to simplify using my order of operations, focusing on the inside of my radical right now, okay? As I do that, I see I need to multiply. I'm going to exponent first, then I'm going to multiply these. Lastly, I'm going to subtract them. Here I ended up adding because I got a negative 44. So minus a negative is addition, okay? That simplifies down to this piece. I then solved my square root. It might be nice. It might be some nasty irrational decimal that you're going to need to round. Lastly, I separated it into the sum version of my numerator, and then one where it's the difference in my numerator. Again, lastly, dividing by 2 to get my two solutions. It seems like a lot of work, but really you're just plugging in stuff and following the same process every time with different numbers. Why don't you take a look at your sheet? Hopefully you wrote down this example. There should be 2 more examples underneath it. For each of them, you're going to get positive or negative numbers. One of them will have a decimal in it. One of them will be both whole numbers. So take a couple minutes, pause the video, and go through and try to solve those. Each of them is going to have 2 solutions, just like this problem did. So let's look at doing another one of these together. Okay, this one's going to have a different type of solution, so I'm going to solve through it, and we'll talk about why it's a little different. So here, example 2. Again, there's a couple things I could do. I could look and see if it's a perfect square trinomial. I could solve using my factoring, Or I could use my quadratic formula. Again, we're focusing on this. You could use different strategies, but pretend the directions are specifically use the quadratic formula to get your solutions, okay? If it says that, you're going to need to know this piece and be able to use this piece. So again, I'm saying commit it to memory, memorize it. Negative b plus or minus the square root of b squared minus 4ac over 2a. It's really long, I'm sorry, okay? But we're going to work at it. You'll practice with it enough that it'll be stuck in your head. So, using this, it is already in standard form. So I'm going to go to my step 2, which is to outline my A, which is 1, my B, which is 8, and my C, which is 16. Okay? Once I've done that, I'm going to plug them into here and then solve using algebra. So, negative B, I have an 8. I'm going to make it negative 8. Plus or minus the square root, B squared, 8 squared. Minus 4 times A, which is 1, times C, which is 16. It's going to be a rather large number. Over 2 times my A value. Again, that is 1. Now we're going to simplify it down. Negative 8, that's going to stay the same, plus or minus. We're going to focus on the inside of this square root sign. This is called the discriminant. We're going to work more with that after vacation. Okay, when we start reviewing stuff, we're going to talk about how this gives us some really important information that's going to tell us about our solutions. And this is going to give us a hint about what's going to happen at the end too. Anyways, we're going to solve it. We start out with the square root of 8 squared, which is 64, minus 4 times 1, which is 4. Okay, or we could say negative 4 times 1 is a negative 4. And then 4 times 16, which off the top of my head, I don't know. 6 times 4 is 24. So we're at 64. So here I'm going to have negative 4 times 16, so I get a negative 64, over 2 times 1, which is 2. Well, look what happens here. 64 minus 64. Well, that's 0. So we're left with negative 8 plus or minus the square root of 0 divided by 2. Now, again, at this point, we would break it off into 2 solutions. We would do negative 8 plus the square root of 0, which is 0, over 2. Or we would have negative 8 minus the square root of 0, which is 0, divided by 2. Negative 8 plus 0, well, that's negative 8 divided by 2, negative 4. And this, negative 8 minus 0, that's just negative 8 divided by 2. Again, we get our negative 4. So in this situation, we only have one x-intercept, one solution, which is going to be negative 4. When you get a 0 under your square root sign, okay, when that cancels out to nothing, every time you are going to only have one solution. And if you think back to what that means if it hits the x-axis only once, it is either the minimum value, the bottom of your vertex, or it's the maximum value, the vertex again. So your vertex is the only point that's hitting the x-axis, and it's going to be at negative 4. So we saw you can get 2 solutions, or you could get 1 solution. Just like the last time, I have 2 examples of where you're going to get 1 solution that I want you to practice right below this one that, again, hopefully you took some notes on. Okay? So give those 2 a try, and that's going to be it. I'm not going to have any irrational numbers to throw at you or any complex numbers quite yet. Practice those, write some good notes, and hopefully you'll do pretty well. We'll talk about this a little bit more on Monday. Thank you guys for watching.